Hi everyone, in this video we will see how to derive ordinary differential equations from any given equation. Now this can be done by differentiating the given equation and eliminating arbitrary constants. Now we shall illustrate this with some examples. Now, given the equation y equals to c1 exponential minus 3s plus c2 exponential 4s, we shall obtain an ordinary differential equation by eliminating these constants c1 and c2. And then, since we have two arbitrary constants, we will differentiate twice. If our equation contains just one arbitrary constant, we differentiate once. So let's differentiate. We have dy dx equals, if we differentiate this, we have minus 3c1 exponential minus 3x. That is, differentiate minus 3s, which gives minus 3, and then multiply this function by that. Plus, differentiate this, we have 4c2 exponential 4x. Let's call this equation 1. Now we differentiate again. We have this squared y dx squared equals, so if we differentiate this, we have 9c1 exponential minus 3x. That is, if we differentiate this guy, we have minus 3. Minus 3 times minus 3 gives us 9. Plus, differentiate this, we have 16c2 exponential 4x. That is, derivative of 4x is 4. 4 times 4 is 16. We'll call this equation 2. And let's now subtract equation 1 from equation 2. That is, equation 2 minus equation 1 gives d squared y dx squared minus dy dx equals, now we subtract them term by term. So we have 9c1 exponential minus 3x minus this now, 3c1 exponential minus 3x plus, now if we subtract 16c2 exponential 4x minus 4c2 exponential 4x, that gives us 12c2 exponential 4x. And this is equal to 9c1 exponential minus 3x, minus times minus is plus. So we have plus 3c1 exponential minus 3x plus 12c2 exponential 4x. And this gives 12c1 exponential minus 3x plus 12c2 exponential 4x. And then we can factorize this as 12c1 exponential minus 3x plus c2 exponential 4x equals, now if you look carefully, the terms here is the same as y. So we have 12y. This expression here equals y. So we have that d squared y dx squared minus dy dx equals to 12y. Or we can write this as d squared y dx squared minus dy dx minus 12y equals 0. So this is our given differential equation obtained from this equation. Now let's see another example. Form the differential equation from y squared equals to c1x squared plus c2x plus c3. Now observe that this equation has 3 arbitrary constants, so we'll differentiate 3 times. Now let's differentiate the first time. We have, if we differentiate this, we have 2y. Now anytime you differentiate a y variable, you need to add dy dx. We learned this from implicit differentiation in calculus equals to differentiate this, we have 2c1x plus differentiate this, we have c2, and when we differentiate this constant 3, we get 0. So we obtain this. Now we differentiate again. Now when we differentiate, this is a product of two functions. So we differentiate using product rule of differentiation. We keep this constant and differentiate this. So we have 2y, differentiate this guy, we get this squared y dx squared plus, and keep this constant and differentiate this. When we differentiate this, we get 2, but because there's a y variable here, we add the y dx times this guy here, dy dx, equals, we differentiate this, we get 2c1 plus the derivative of a constant is 0. So we have 0 there. Now, since 2 is common to the terms, we can divide through by 2 to get y, the squared y dx squared plus dy dx times dy dx, or dy dx squared, equals c1. Now let's now differentiate the third time. Now this is also, we differentiate this by the product rule of differentiation. So we keep this constant and differentiate this to get y d cubed y ds cubed plus, keep this constant and differentiate this, we get, now when we differentiate this, we have 1, but because this is a y variable, we need to add the y dx times, keep this constant, we have the squared y dx squared. So we have applied the product rule of differentiation to get this. Now plus this term here, and we also differentiate this using the product rule of differentiation to obtain 2 dy dx times d squared y dx squared. Now let's see how we obtain this. So we have so differentiate this using product rule. If we keep these constants and differentiate this, we have dy dx times d squared y dx squared plus, keep this constant, differentiate this, we get the same thing, dy dx times d squared y dx squared. So we have 2 of these, and that gives us this, equals, we differentiate c1 is a constant, we obtain 0. So this implies that y d cubed y dx cubed plus dy dx times d squared y dx squared plus this gives us 3 dy dx d squared y dx squared equals 0. And this gives the differential equation obtained from this equation. It's a differential equation of order 3 because we have 3 arbitrary constants. I hope you enjoyed this video. If you have any question, you can drop them in the comment section. Thank you.